Hi, it's Nature Jack. Welcome back to Science with Nature Jack. Today we're learning about matter, M-A-T-T-E-R. Everything in the world is made of matter. There are three states of matter. There's solids, liquids, and gases. Instead of me telling you about the three states of matter, how about if I sing it in a song? It's time for the Three States of Matter song.
A 1, 2, 3, 4.
Solids, liquids, and gas. The three states of matter, they all have mass. Solids, liquids, and gas, they all have mass. A solid is firm, a solid is hard, just like the tree trunks in my backyard. A liquid is wobbly, a liquid is loose, just like soda, water, and juice. Solid, liquids, and gas, they all have mass. A gas is the hardest one to see. It's invisible, not like me. Solids, liquids, and gas, they all have mass. The gas inside this balloon, you blow it up, you watch it zoom. Solids, liquids, and gas, they all have mass. Let's read a story about solids, liquids, and gases. Solids, Liquids, and Gases by Dorothy Heil. Matter in the world. The fish are swimming in water. The kite is flying in air. A truck drives down a road. Fish, water, kites, air, trucks, and roads are all made of matter. Anything that takes up space is matter. You matter. Big idea question. What are solids, liquids, and gases? Solids, liquids, and gases are matter. Scientists call them the states of matter. This picture shows the three states of matter. The buildings are solids, the water is a liquid, and the air is a gas. Liquid, solid, and gas. Solids, solid man. The toy robot is made of metal. The metal robot is a solid. A solid is matter that has its own shape and takes up space. A bicycle wheel is a solid. How would you describe the bicycle wheel? Do you think it's round? Is it like a circle? Is it solid? Liquids. This juice takes up the space of the pitcher and the glass. The juice is a liquid. A liquid takes up the shape of its container. It does not have a shape of its own. Milk is also a liquid. What happens if it spills or overflows? It spreads out over the table. A liquid does not have a definite shape when it is not in a container. Gases. Air is a gas. It fills up all the space around you, even though you cannot see it. A gas does not have a definite shape or size. It spreads to fill a space. Your breath is a gas. You use it to blow up a balloon. The gas spreads out and fills up the balloon. Everybody take a deep breath and blow it out. You're breathing in and blowing out gases. Big question. How do liquids and solids change? Liquids and solids can change states. You have probably seen water, a liquid, change into ice, a solid. Ice can also change back into water. Matter can change states. How does water change into ice? Cold temperatures can cause liquid water to freeze. When water freezes, it turns into solid ice. It changes from a liquid to a solid. Hot temperatures can also cause matter to change states. Heat can cause solid ice to melt into liquid water, Add more heat and liquid water can turn into a gas called water vapor or steam. Solids can mix with water. Some solids change when they are mixed with water. Sugar is a solid. When you mix sugar with water, the solid sugar changes. It dissolves in the water. The sugar and water become a solution. Mix it together, it dissolves. Some solids do not dissolve in liquids. Sand does not dissolve in water. Sand and water do not become a solution. They are two separate things, so they're actually still a mixture. Matter can change shapes. Solid matter can change shape. It can be bent, folded, cut, chipped, broken, or torn. All matter does not change in the same way. You can fold a piece of paper to make a new shape, but a cracker will not fold. It breaks into pieces, but they are still solids. Solids, liquids, and gases are the three states of matter. Matter has properties that you can observe and measure. Matter can change. Solids and liquids can change from one state of matter to another. When water freezes, it turns into ice. When ice melts, it turns into water. Solid matter can be bent, folded, cut, chipped, broken, or torn. All matter does not change in the same way. Gas, solid, and liquid, they all have mass. I bet you're wondering what that song really means. Solids, liquids, and gas, the three states of matter, they all have mass. What is mass anyway? Well, mass means anything that takes up space. So let's look at this tub. This blue and clear tub takes up space. Look, I put it on my knee, and it's sitting on my knee. It's taking up space. Let's see what's inside this tub to explain also what takes up space and is mass. Let's see what the mass is. So, look at these books about matter. They all take up space. Every book takes up space. And look at this bottle. This bottle takes up space, and inside this bottle is filled with air, and air takes up space. How do we know that air takes up space, or that gases take up space? Well, you might remember from the song that when you take a balloon and you blow into the balloon, the gas coming out of your mouth, which is carbon dioxide, fills up the balloon, so the air or the carbon dioxide takes up space. Watch again. So if you set this balloon in my hand, you see the balloon takes up space because the balloon is filled with a gas, which is carbon dioxide. It takes up space inside the balloon. I'm going to let the balloon go because it zooms away. Gone. Now the balloon sits on the ground. It still takes up some space. Now if you take this jar, which is filled with a gas called air, and you put this funnel on top of the jar, and then you take a pitcher of purple liquid, which is actually water, the water takes up space in the pitcher, and the pitcher also takes up space, which I'm holding with my hand. What I'm going to do now is I'm going to take the liquid and water and pour it into the jar. It's going to take up the space where the air was inside the jar. So let's watch that. So look at this jar. It's filled with air. I'm going to displace the air with this water. So the water will take up the space of where the air is. Watch. What's really cool about water, which is a liquid, is liquid takes up the space of wherever you put it. It doesn't take up its own space because it doesn't have any shape. But if you put it in this bottle, it takes up the shape of the bottle. So now I poured the water, which is a liquid, into the jar, which is a solid, and the water is taking up the space. This much space is water or liquid, and this much space is still air. Now they both have mass because they take up space. The liquid has mass, the gas inside has mass, and the jar has mass. They all have mass. Solids, liquids, and gas, the three states of matter, they all have mass. So look at this tub or box. Is there anything inside of this box? Does anything in here take up space? You might have guessed that it's filled with air. Oh, fresh air is inside this box or tub. It's filled with air. Air takes up space. And air has mass. Air is a gas. Gases have mass. Now that you've seen some solids, some liquids, and gases, and that they all have mass, let's read an awesome book about solids, liquids, and gas. They all have mass. Let's find out more about just gases. So this book is called What is a Gas? This page is titled What is the Matter? Matter is all around you. Matter is anything that takes up space. Mass is the amount of material or something has. Matter can be sorted into three states: solid, liquids, and gas. Air is a gas that takes up space. It's used to pump up tires. It is a gas. Did you breathe in a gas today? If you are alive, then the answer is yes. Air is an invisible gas. It flows in and out of your lungs every time you breathe. Why don't we all breathe in and breathe out? This page is titled Taking Up Space. A gas takes up space. Even though you cannot see some gases, they are still there. You can see this when you blow up a balloon. You fill the balloon with the air from inside your lungs. It's called CO2. You see these balloons? No shape of its own. A gas that does not have its own shape, it spreads out to take the shape of the thing you put it into. Air that you breathe in takes the shape of your lungs. The air you breathe out takes the shape of the room you're in. When you blow up a balloon, it's filled up with air. What do you think? Put a straw in a glass and fill it to the very top with water. Blow air through the straw into the water. What does air inside the water look like? How do you know it takes up space in the water? Well, you can see the bubbles coming out of your straw, and those bubbles are filled with the air you blow through the straw. This experiment sounds awesome. Why don't we try it out? All right, here's our experiment. We have a glass of water, a straw. I'm going to blow the air from my lungs into the water. It's going to make bubbles, and the bubbles are going to be filled with gas. So if you look at those bubbles, the bubbles are filled with gas, carbon dioxide coming out of my lungs. And the gas takes up space inside the bubbles. Watch again. Now that we've read a book about gas, let's do an experiment where we turn a solid into a gas. This is a piece of dry ice. Dry ice is much different than the ice we take out of our freezer. Dry ice is solid. It's solid carbon dioxide. Scientists found a way to freeze carbon dioxide gas and it becomes a solid. So it goes from a gas to a solid. Dry ice doesn't melt. It sublimates. It turns right into a gas. And you can kind of see the gas coming off the dry ice. What's really cool is if you take dry ice, I'm going to pour in some hot water from our tea kettle here. You can see the steam, so you know it's hot. If you take dry ice and put it into a bowl of hot water, it immediately turns it into a lot of gas. Wow. Isn't that cool? Can you see it? Wow, all that steam or water vapor is carbon dioxide going back into the air. You know what's even cooler? If you take dry ice in water, hot water, and you pour in some dish detergent, it makes bubbles filled with carbon dioxide. Can you see it? Can you see the bubbles filled with carbon dioxide? So you can see all these bubbles are filled with the gas, carbon dioxide. So the ice is still inside the bowl. Look. Here it is. It's solid carbon dioxide, dry ice. And when you put it in warm water, it turns into a gas. That is such cool stuff, huh? You could try this at home. You just have to go to the store and buy dry ice. Dry ice is filled with gas. Should I put some more bubble? There's a bubble. Wow.
Don't pop it yet.
Whoa.
Whoa.
Whoa. Wow. Now that we've seen how dry ice can turn into a gas, carbon dioxide, let's see how we can make the same gas, carbon dioxide, mixing baking soda with a different liquid. So now we're going to do another experiment. We're going to take this empty bottle and we're going to pour a solid baking soda and a liquid vinegar into the bottle together, and we're going to see what happens. So I'm going to take this funnel and I'm going to pour the baking soda through the funnel down into a balloon. And watch what I do. I'm going to take this, pour it right through the funnel. I'm going to try to fill up the balloon with baking soda. So we're going to shake it so that a lot of the baking soda goes into the balloon. We're going to lower the balloon so we can fill it up a little bit more. And now the balloon is filled with baking soda. See? As you can see, baking soda is a solid. Next, I'm going to take vinegar and I'm going to pour it into this bottle. I'm going to pour some vinegar into the bottle, and you can see that vinegar is a liquid because it's pouring into the bottle. It's loose and wobbly. Liquids take up the shape of the container you put them in. So this bottle is filled with liquid vinegar, and you can see that it stays inside the shape of the bottle. Now I'm going to take the balloon that's filled with baking soda, which is a solid, inside the balloon, and I'm going to take the neck of the balloon and I'm going to put it over the top of the bottle. So now you can see the vinegar is inside the bottle and the baking soda is inside the balloon. And when I lift up the balloon, the baking soda is going to go down into the vinegar, and when you mix baking soda and vinegar, it makes a gas called carbon dioxide. And if this experiment works, the balloon will fill up with the gas, carbon dioxide. Let's watch. Here we go. Whoa, did you see that? Whoa, whoa, look at that gas coming out. Isn't that amazing? Science is so cool. Look at all those bubbles filled with carbon dioxide. Even though the balloon split apart, it still showed you that gas is made when you mix vinegar, a liquid, with baking soda, a solid, creates a gas called carbon dioxide. Let's try that same experiment again with a different balloon that might work better. So we're going to take our bottle here and we're going to put vinegar in the bottle, just like we did before. And this is vinegar, which is a liquid. It takes up the shape of the container it's in, and we're going to pour the vinegar into the bottle. So now we have vinegar in this bottle. And then we're going to take our balloon and we're going to put baking soda, which is a solid, into the balloon. You want to get as much as you can into the balloon through the neck of the balloon. And then we're going to take our balloon, which is actually made out of a solid, it's filled with baking soda, and we're going to take the neck of the balloon and we're going to put it over the neck of the bottle. So you have a solid bottle, liquid vinegar, solid baking soda inside the solid balloon. We're going to lift up the balloon. The baking soda will drop into the vinegar, create carbon dioxide gas. The bottle will fill up with that gas, and because the gas can't escape because the top is closed by the balloon will fill up with the gas. It will inflate. Let's watch what happens. Check it out. Whoa, is that cool? Oh my goodness, look at that. Wow, that really worked much better, didn't it, Nature Max?
Absolutely, Nature Jack.
And you know what else is cool? Now that the balloon is filled with all that gas, if you release the balloon from the bottle, it's going to shoot away just like a balloon filled with helium. That's really cool. This is the Earth. The Earth is a sphere. And you can see on the Earth that it's covered in mostly blue color. And that blue color is water. So the Earth is covered in water. We call the Earth the water planet. And that water is a liquid. And there's lots of water on the Earth, not just covering the Earth in the oceans, but also in other parts of the world. You can find water in vegetables and fruits. And inside this banana is a cup of water. And this lemon is also filled with water. If you cut a lemon in half, the water coming out is lemon juice, and that's a liquid. And also, this is a papaya. A papaya is filled with water. It's so heavy because it has so much water inside. I'm going to slice it open and show you what it looks like inside. Look inside there. If you can see it, it is actually dripping with water. Papayas are filled with water. So a lot of the water on the Earth is inside fruits and vegetables. This is a red pepper. A red pepper is also filled with water. There's a whole cup of water inside this single red pepper. So you can imagine the millions and millions of peppers that are grown every year are filled with cups of water. That's a lot of water. That's fresh water that's not in the ocean. Another example of a fruit filled with water is a lemon. A lemon has about a quarter cup of water inside it. In fact, if you cut this lemon open, you'll see all the water come out. Let me show you how that looks. Wow. As I told you, the Earth is covered in water, which is a liquid, but inside the Earth, it's filled with rock, like this rock. And rock is solid. So rock solid has a lot of matter, because all matter is a solid, a liquid, or a gas. Now I'm going to take this deflated Earth balloon, and I'm going to use the air from my mouth to blow it up. Watch. So I use the carbon dioxide gas in my lungs to fill up this Earth ball. Did you know that the Earth is also covered in air? And air is part of the atmosphere surrounding the Earth. So there's a layer around the Earth filled with air called the atmosphere. And all the times you use gases on the Earth, they float up into the atmosphere. And what we're going to do today to show you how that works is I have a fire pit here. I'm going to light this fire. The wood is going to start to burn. It's going to burn off into a gas, and the gas is going to go up into the sky and into the atmosphere surrounding the Earth. So let me show you what happens when I take a match and I light this fire.
5 minutes later.
As this fire is starting to light and burn, you can see the smoke coming up from the fireplace, and the fire is creating smoke, which is a gas, and the gas is going up into the sky here, and it's going to go into our atmosphere surrounding the Earth. Now that we've done an experiment where we've changed the shape of gas, let's do an experiment where we change the shape of water or liquids. We're going to do an activity to show you how water takes up the space of the container it's in. This is a water bottle, it's a container, and inside the water bottle is red food coloring, which is a liquid. And you can see that the liquid takes up the shape of the container. When I pour it, it goes right along to the shape of the water bottle. Now I'm going to pour some of this red food coloring out of the water bottle into this vase, which is filled with water, which is a liquid, of course. Watch what happens. Now, I don't know if you can see it, but the vase just turned red, and the water or liquid is inside the vase, and the water, the liquid, is the shape of this beautiful red vase. Now I'm going to take the same water and pour it into a different container to show you how it takes up the space of this container. I'm going to use a funnel to pour it in here. I want you to watch how the water inside this vase, the same water or liquid, fills up this container. Check it out. It's the same water, the same liquid, but it's in a different shape. This is a straight cylinder, and you can see all the water is in a different shape. It's even taller than the pitcher because it's a different shape. Now we're going to take the same water and pour it into this big round gallon jar. Now watch how it fills up the jar. The liquid takes up the shape of this large gallon jar. So you can see it's already a different shape. It's much lower, but it's the same volume or the same amount of liquid. Now we're going to take the liquid from this jar and pour it into this pitcher, which is another shape. And now you can see it's a completely different shape, but it's the same volume or amount of liquid. Now I'm going to take this pitcher and I'm going to pour it into this science beaker. And now you can see that the same liquid is now in this beaker, and it also has a different shape, but it's the same liquid. Now we're going to take the liquid that's in this science beaker and we're going to pour it into a flat aluminum pie pan. Remember, liquids pour and they take up the shape of wherever they are put. So in this aluminum pie pan, it almost looks like we're making a pie pan of Jell-O. And to move, see how it moves in the pie pan? It takes up the shape of this container. So finally, we're going to take the water, the same water that was in the vase over there, into this cylinder, into the large jar, into the pitcher, into the science beaker, into the pie pan. We're going to re-pour it back into the original red vase and see what it looks like. It's the same amount of water, exactly the same, in the original pitcher. Isn't that amazing? That's because liquids take up the shape of their container. Now that we've done an experiment where we change the shape of liquids, let's do another experiment where we mix two liquids and a solid and see what else we can make. So this fire is burning now, creating gas that's going up into the atmosphere. And I'm going to let the fire continue to burn because it's going to keep us warm while we do our next two experiments. We're going to take solids and we're going to mix them with liquids, and we're going to see what happens. So for our first experiment, we're going to take cornstarch, which is very easy to find in the store, and we're going to pour cornstarch into this first bowl. When you pour cornstarch, it makes dust. It actually looks like smoke, but it's just dust. So, can you see the dust? Great. And the next thing we're going to do is we're going to take some food coloring. I chose pink today. And we're going to sprinkle the pink food coloring all over the cornstarch. Can you see the cornstarch? Great. Now all you have is a solid with a liquid inside. The solid has soaked up the liquid food coloring, so it's still really just a solid with a little bit of coloring in there. Remember, matter is solids, liquids, and gases. Now we're going to take our liquid water. You can see water takes up the container, the shape of the container it's in, and we're going to pour some of this water liquid into the cornstarch, and then we're going to mix it together. Now that I've mixed the cornstarch and water, so the solid and the liquid, and the food coloring, which is also a liquid, I've created something called oobleck. When you pick up oobleck, it looks like a liquid. But when you rush your hands to the solid, to the middle, and you hit it, it doesn't splash. Look at that. It doesn't splash, so it feels like a solid. It's really hard when you hit it. But then when you put your hand in it, your hand goes right into it just like a milk liquid, like a liquid. So here we are with our liquid oobleck. The molecules in this liquid are just moving around freely, but then when you go to hit it, it acts like a solid. It doesn't splash. If you had a bowl of milk here and you did this to it, it would splash everywhere, but oobleck doesn't do that. So I've taken my liquid food coloring and my liquid water, and I mixed it with my solid cornstarch, and I've created this oobleck. Oobleck is a great example of a non-Newtonian fluid. It acts like a solid when you hit it, but it feels like a liquid when you play with it. So if you pick it up, it looks like a liquid. If you hit it, it acts like a solid. This is a great example of two different kinds of matter mixed together, acting differently. Solid or liquid. Now we're going to do a different experiment. I'm going to mix two liquids and a solid and then another liquid, and we're going to see what we get out of that. So first we're going to take cornstarch. You can buy cornstarch almost anywhere, any supermarket or at Walmart, and you can pour the cornstarch into the bowl. And when you pour cornstarch, it makes a dust. It actually looks like smoke, but it makes dust. You can see that dust. So now we have cornstarch in our bowl. And what I'm going to do is I'm going to take liquid food color and I'm going to pour it into my cornstarch to give it some color. Then I'm going to take my hand, I'm going to mix that liquid and the solid together. It's not going to look like much different when you mix it up until you add the liquids, because the food coloring won't really mix until it becomes a solution, and that's when you have a liquid mixture. So now we have our cornstarch, and now I'm going to take my dish detergent. Any brand is fine, and you can see how the dish detergent, which is a liquid, takes up the shape of the container or the bottle it's in, because that's what liquids do. So you can see how the liquid moves in the bottle because that's what liquids do. Now I'm going to pour some of this liquid into my solid mixture. And now I'm going to mix it with my hands. And what you end up with is kind of a gritty mixture. You can see that. It's kind of a solid, but it's also very flaky, and we call it gritty. So it's no longer as dusty as it was before, but it's still a solid mixture. And now I'm going to add water, and of course you know water is a liquid, which also takes up the shape of its container or this pitcher. You can see in there the water. And I'm going to pour my liquid water into this bowl, and I'm going to mix it up with my hand. Now it's a little bit too liquidy for me, so I'm going to add a little more cornstarch, which is also a solid. And now I'm going to mix it up in my hand. So now I'm going to take this thing, and it's becoming like a solid, like that. See how solid it is? It's a little bit different than oobleck. It doesn't flow quite as fast, but it's still kind of a solid and a liquid at the same time, but it has a really cool color. You see that? I think if we add more cornstarch, it'll become even more of a solid. So it's like a really cool, fun, solid thing to play with. It moves a little bit. It's not quite the same as oobleck, because you can see it still retains or holds on to its shape. It actually looks like a sphere or maybe a brain. So it's really fun to play with. So this is one of my pet frogs. And you can see a frog lives in water. There you go. And a frog is filled with water as well. So all living things, all living animals, have water inside their bodies, and some of them actually live in water. Okay, my fellow scientists, this is a frog. A frog is a solid. But a frog has lots of water or liquid inside of him. He can't live without water, neither can you. Most of your body is filled with water, same as this frog, but you know what else? Trees also use water to live. The tree soaks up water through its roots. It goes up all the way into the tree, and in the spring, the tree uses its leaves and water to make food for itself. So without water or liquids, a frog couldn't live, a human couldn't live. In fact, there's no animals in the world that can live because they all need water to live. Even fish that live in water have water inside their bodies. And so do all plants. All plants use water or liquids to grow. For our final experiment, we're going to use diet soda and a special candy, and it's going to create a huge amount of gases inside bubbles. For our next experiment, we're going to talk about taking a solid, mixing it with a liquid, and turning it into a gas. So today's experiment starts off with a bottle of Diet Cola. Now, you don't need Diet Coke. You can use any brand. I bought this brand at Walmart. It's called Sam's Club Cola. It's Diet Cola. And cola is made by mixing water and caramel, which is a flavoring, and food coloring, and something called carbon dioxide, which is a gas. It's the most prevalent gas on the earth. It's inside your body, it's inside trees, and it's inside all types of liquid. Scientists have found a way to put carbon dioxide into liquids, and it becomes carbonated. So when you have a bottle of carbonated soda or carbonated seltzer or anything carbonated, when you open up the bottle, you hear the gas coming out. It makes a hissing sound. So let's open up the bottle and listen to the gas coming out. Did you hear that gas, that pop? That's the sound of the carbon dioxide coming out of the bottle. I'm going to screw the bottle cap back on. Now what you have here is a bottle of diet soda. And this bottle is a solid. It's made of a solid. When you hit it on the table, it makes a sound because it's a solid. And you can see that the liquid inside the soda is wobbly. Remember how I told you that liquids are wobbly? Listen to the carbon dioxide gas coming out of the bottle when I open the bottle. Did you hear that? That's the gas coming out of the bottle. Now what we're going to put inside of this bottle is a candy called Mentos. Have you heard of Mentos before? Mentos are a candy, a minty candy, that comes from the Netherlands in Europe. And Mentos are very special because on the outside of a Mento are thousands of little bumps called dimples, kind of like a golf ball. Let me show you this golf ball. If you look at the golf ball, it has all these bumps on it. Those are called dimples. Mentos also have dimples on the outside of the shell. So each Mento has thousands of dimples on the outside. But the dimples on the Mentos are so small you can only see them with a microscope. And what happens is when you drop a Mento into the Diet Cola, all the bubbles want to surround or circle themselves around each dimple, and then you have millions of bubbles attaching themselves to each Mento, and they hug the Mento. And when you have millions of bubbles hugging all these Mentos, they want to come out of the bottle. So the Mentos are going to shoot up with the soda, and the soda is going to turn into gas. Are you ready to see some gas made out of liquid? If I dropped one Mento into this bottle, the liquid would turn into a gas. It would come out of the bottle. But what if I could put more than one? Maybe 1, 2, 3, 4, 5, 6, 7 Mentos at one time. That would mean all the bubbles would come out of the bottle. The liquid would turn into a gas immediately and shoot up into the sky. Would you like to see that? So we're going to take these Mentos, which are solid candy, and we're going to put 7 Mentos into this whole bottle of Diet Cola. And all the Diet Cola is going to immediately turn into a gas, and the gases are going to shoot out in the form of bubbles. And every bubble is filled with carbon dioxide. So I have a special Mento launcher on the bottle here so I can launch or load 7 Mentos. Let's do it right now. 1, 2, 3, 4, 5, 6, 7. And I'm going to put this top on there. Now we've loaded the 7 Mentos. 1, 2, 3, 4, 5, 6, 7. And we're going to launch it, and it's going to go, all the Mentos are going to go right into the soda, and immediately the soda is going to turn into a bubbly mix filled with gas, and all the bubbles are going to shoot out, and they're all going to be filled with carbon dioxide gas. Are you guys ready? Are you ready?
10.
Let's do it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's make some gas. Wow. Wow, look at that. Oh my goodness. All the soda turned into bubbles, and it's filled with carbon dioxide. Gas blast off. Wow, it's going up. So cool. All the gas came out of the soda. Science is so exciting.